Hi, this is the geometry problem solving series for Olympiads. This is question number 2. The first video is already up there. I selected this problem not because it is hard, it is fairly straightforward, but because it helps you revise a little bit of the properties of triangle and trigonometry theory that you need to know to do Olympiad problems. So if you want references for the trigonometric portion here, you should go to SL Loney. That is definitely the best book for properties of triangle and trigonometry. And you should look at chapter 12 and chapter 15 in the SL Loney textbook. But for now, let's get back to the problem. The problem is an actual Olympiad problem, but it's a very old problem. So it's fairly straightforward. The triangle ABC has semiperimeter P. Find the length of the side A and area del in terms of angle A, B, and angle and P. So let's get to it. We'll do it by using sine rule. So sine rule for a triangle says that A by sine A is equal to B by sine B is equal to C by sine C, and that is equal to 2R, right? And we have here semiperimeter P is equal to A plus B plus C by 2, right? So therefore, what we can write is P is A is 2R sine A, B is 2R sine B, and C is 2R sine C. Therefore, P will become R common sine A plus sine B plus sine C. Sine A plus sine B plus sine C. And what you can do now is you can write R in terms of P. So P by 2, R is correct. So 2R is A by sine A. So basically R is equal to P by sine A sine B sine C. Sine A plus sine B plus sine C. Correct. So what now we will do is we will express this A by sine A and this third one, and we'll use the first and the fourth portion of this equality. So A by sine A is equal to 2R, and put the value of R as this because we want to express everything in terms of P, A, and B. So we get 2P by sine A plus sine B plus sine C. And this already is close to what we need because we have sine A, we have P, we have A and angle B, but the only problem is angle C, which is fairly straightforward. What we'll do is A is equal to 2P sine A by sine A plus sine B plus sine C, sine B plus sine C. And at this stage, you can use the identity in a triangle. Sine A plus sine B plus sine C in a triangle is always 4 cos A by 2, cos B by 2, and cos C by 2. This is again an identity from SL Loney. This is in chapter number 9 of SL Loney. So you should get back to that book and check it out. Very straightforward identity. You will get the proof. So therefore, what we can say is A is equal to 2P sine A by 4 cos A by 2, cos B by 2, cos C by 2. And now we have to somehow remove C by 2. So what we can do is write it on top as 4P sine A by 2 cos A by 2 by using the double angle formula for sine, and divide by 4 cos A by 2, cos B by 2, and cos C by 2. So 4 cos A by 2 gets cancelled, and you get P sine A by 2 by cos B by 2 and cos C by 2. But I don't want to write it in terms of cos C by 2. I have to use my A and B angles. But I know that since it is a triangle, sine A plus B by 2 will be equal to cos C by 2, because A plus B plus C is pi. Therefore, A plus B is pi minus C, and A plus B by 2 will be equal to 90 minus C by 2, or pi by 2 minus C by 2, I should have written. And now if you take a sine here, sine pi by 2 minus C by 2 is cos C by 2. So therefore, I can replace this part like this. And this becomes my answer for A in terms of the things that the question asks. Question asks to represent A in terms of these things. P as angle A and angle B. So we have done that. So that is the first part. And now we also have to represent it, the area of the triangle in terms of these quantities. So let's do that second part. It is again fairly straightforward. Area can be written as half AC sine B. This is simply half base into height. You should draw the figure and you'll realize that this is true. And then that becomes half A sine B into, instead of C, I can write A sine C by sine A. A sine C by sine A. How do I know that? Because A by sine A is equal to C by sine C. So C is equal to A sine C by sine A. And this area now becomes A square sine B sine C by sine A by 2 sine A. A square sine B sine C by 2 sine A. You can leave it here by just writing it like this: sine B sine A plus B by 2 sine A. Or you can actually go ahead and simplify it using the expression that we got for A. A had come for us as P sine A by 2 by cos B by 2 and sine A plus B by 2. If you use this expression for A that we derived in part 1 and put it into this expression, right? And after that, simplify using double angle formulas. So sine B can be written as 2 sine B by 2 cos B by 2. And similarly, sine C can be written as 2 sine C by 2 cos C by 2. And similarly, simplify for sine A as well. So what will come finally after all of these simplifications is a nice expression, which is P squared tan A by 2 tan B by 2 and cot A plus B by 2. Cot A plus B by 2. So I have done these calculations myself and I have gotten it. You will also be able to get it fairly easily. I'm just not showing these steps because it's simple manipulation and cancellations. So it's fairly straightforward. The problem is very easy. The reason I am showing this problem is because you need to know all of these identities in a triangle. The trigonometric identities in a triangle are super important, and you should go back to SL-Loney, know these identities. Like, for example, the sine A plus sine B plus sine C is equal to 4 cos A by 2, cos B by 2, cos C by 2. That one can be proved by a simple sine A plus sine B formula. So get to the revision of your trigonometric stuff pretty soon, because that comes in handy a lot in Olympiad problem solving. That's it for this video. I'll be making more of this content shortly, and stay tuned.